Good afternoon, everyone. Good afternoon, sir. So today, I'm going to present to you mathematics in nature and sets. First that I'm going to talk about is the mathematics in nature. Mathematics is everywhere. It is an object we create in the works of art we admire. Although we may not notice it, mathematics is also present in natures that surrounds us. In its landscapes, species, animals and plants, including human species. Our attraction to other human or even our mobility depends on it. But how does this happen? I will read for you the definition and examples. Pattern is a series of sequence that repeats based on a rule. So for example, here in my presentation, we can see 4 dominoes shall be arranged. To arrange them, a rule must be considered in playing dominoes. So thus, the arrangement of 4 dominoes must be like this. So the first dominoes presents A, 5 and 6, B, 3 and 4, C, 6 and 6, and then D, 5, 4 and 5. So in the second figure, it is now B, 3 and 4, next is D, 4 and 5, then A, 5 and 6, and then C, 6 and 6. And then next is, here's the classification of the most common patterns in nature. Symmetry is a pattern that shows reflection of images. So, as you can see, figure 1.1, symmetry of a starfish and a fly. So, symmetry has 2 classifications. Radial symmetry, a symmetry formed around a central axis. On the other hand, bilateral symmetry is a symmetry in which similar anatomic parts are arranged on opposite sides of a median axis so that only one plane can divide the individual into essential identical halves. Here are some examples of symmetry in nature. So, starfish is an example of a radial symmetry. Animals with radial symmetry all live in water, such as sea urchin and jellyfish. Most of them can't move very quickly. Another example of a bilateral symmetry is a butterfly. Butterfly is a perfect example of a bilateral symmetry because its wings are identical to each other. Another pattern is fractal. Fractal is a pattern which repeats progressively smaller sizes and angles. So as you can see in the figure, 1.2 shows Pascal triangle is introduced by Blaise Pascal. Fern is an example of a fractal. It has its natural pattern. Its stems and leaves are patterned from bigger to smaller measurements, but with the same shape. Another example is an aloe vera. Aloe vera is an example of fractal because its leaves have similar shape but do not have similar sizes. It also has a spiral pattern. This type of plant has a spiral fractal characteristic, which most commonly called as spiral and tessellation. Tessellation is a tiling over a plane with one or more figures such that the figures fill the plane with no overlaps and no gaps. A very common example of tessellation is a honeycomb. Honeycomb structure is natural and is created for efficient use of space. Pineapple fruit is an example of tessellation, but can also be fractal because of its ring. I will now proceed to sets. Sets are collections of objects. It can be presented as capital letters and curly braces. Each object in the sequence is called element. Sets can be identified in different methods. So first method is rule method. Rule method is describing a set by indicating the properties that its numbers must satisfy. Rooster method. Rooster method is listing elements inside a pair of braces. A subset. Subset is a set whose elements are all members of another set. The shows below are symbols. The following diagram shows an example of subset. Universal set is a set that contains all the elements of a given set. It is denoted by U. The cardinal sets. The numbers of elements in given set. So example, let S be the set with the following element. So set S has element B, C, D, F, G, and H. The cardinality of the set is the total numbers of elements. We now proceed to set operations. So union. Given set A and B, the union of the two sets is defined as the set of all elements that belongs to either A or B, or both A and B. Next is the set, given set A and B, and the set B. Set difference of two sets is defined as the set of all elements that belongs to A and does not belongs to B. Complements the elements present in the universal set. Universal set has element 2, 4, 6, 8, 10, and 12. And set A has element 4, 6, and 8. Then the complement of set A has element 2, 10, and 12. So that is how we get complement. So that is all of the presentation. Thank you for watching.